My name's Katie Cameron, and I'm the coordinator for the Eastern Nebraska Water Resources Assessment Project, or ENWRA. I'm also a hydrogeologist with the Conservation and Survey Division, your State Geological Survey, School of Natural Resources, University of Nebraska-Lincoln. The ENWRA group formed in 2006 when the 6 Eastern Nebraska NRDs, so your Lewis and Clark, your Lower Elkhorn, your Papio, Missouri River, your Lower Platte North, Lower Platte South, and Nemaha NRDs, formed a coalition together with agencies and experts in the state, your USGS Water Science Center in Lincoln, your State Geological Survey, the CSD, the Nebraska Department of Natural Resources, and the Nebraska Department of Environment and Energy. So they all set out together as a unified group to assess the hydrogeology of eastern Nebraska together. And they used a variety of different assessment tools across the 15 years. But in the most recent years, Airborne Electromagnetic Survey, or AEM survey, has been one of the prominent. AEM surveys are conducted with a fixed wing or a helicopter aircraft, and they have geophysical equipment hanging below. So in the beginning, we started using a torpedo-shaped piece of equipment, and then from about 2013 on, we moved to the hoop-shaped piece of equipment. And since the 2013 timeframe, we've used almost exclusively the SkyTem time domain system. So I'm not going to go into the geophysics of the method, but as the helicopter's flying along, it goes about 50 miles an hour, and then it tries to keep that hoop so that it's about 100 to 150 feet off the land surface. And it knows where it is in 3D space above that land surface at all times. And as it's going along, what we end up with is a virtual borehole of apparent resistivity values of the sediments with depth. And they're summarized every about 60 to 150 feet under that flight line and interpreted. So geophysicists take those large data sets and then they process them, and sometimes it takes a long time. They have to process a whole day's flights overnight. And there's a lot that goes into it, but what you end up with is almost like a profile scan of the subsurface where the different sediments show up with distinct contrasts. So your aquifer materials, so your coarser deposits, more like sand and gravels, they'll show up with high resistivity values, and your clays and shales will show up with low resistivity values, or because they're more conductive. And so we can map out where the non-aquifer and the aquifer materials are. Now you lose resolution with depth on these, but with the most recent flights that we've done, we could see at least 600 feet down. And when you have many of these different flight lines all stacked together in a tighter space formation, you can infer between these profile scans and find out what the volume of the aquifer materials are in that specific area. So eastern Nebraska is completely different than western Nebraska, where they have the high plains aquifer that's more readily available and well understood. The glaciers came into eastern Nebraska like a bulldozer, and they left an irregular bedrock surface. And they dumped any variety of materials from clay-sized particles up to boulder-sized particles in no particular order. So it's really difficult to assess the hydrogeology of eastern Nebraska, and our topography changes and the subsurface changes all over the place. So you can have people using water out of glacial outwash deposits with their wells in one area, go a couple hundred feet away, and have a completely different hydrogeologic situation going on, or no aquifer material available. So the airborne survey methods, along with all the other assessment data that we've collected over the years for the region, is a rapid, cost-effective way to get at that framework. So the framework is, where are the aquifers? How deep are they? Where are they potentially connected with surface water sources? Are they shallow? Are they deep? Are they connected with other aquifers? That framework is what we tried to build with the airborne surveys. Building the framework has been one of the primary goals of the ENWRA group since the beginning. So by the 2018 timeframe, when we went for this large Water Sustainability Fund grant, we were able to fill in a lot of the gaps in the areas where we were missing data. And between June 13th and July 26th in 2018, we flew 7,000 line miles across the whole region for those 6 NRDs. And out of that, we were able to get 2,000 additional bonus flight lines beyond what we proposed in our grant application. So we had proposed about 4,000 to 5,000, and we got 7,000. And that was due to a couple different factors. We had really good prices from the geophysical vendors. We also had the Lower Elkhorn NRD and the Lewis and Clark NRD take advantage of that price opportunity to fill out the 3-mile grids in their districts and also do a couple more focus areas. And the remaining NRDs, if you can see on this map, here's a version of the interpreted data flight lines from the 2018 grant application. You can see the NRDs were able to tie into both the 3-mile grids of the Lower Elkhorn and Lewis and Clark. They were able to go into certain groundwater development areas and do focused flight lines. They did 1-mile and 2-mile grids, and then they also covered many of the community water supply wellhead protection areas with tighter space lines so they could get the volumes. In addition to the 2016 AEM flights and the 2018 surveys that I just talked about, we had 2019 surveys and 2020 surveys with Water Sustainability Fund grant money where the NRDs went for that. But the Nebraska GeoCloud is another AEM-related Water Sustainability Fund project, but it's a statewide project designed to house all that airborne data collected in the state in one consistent format with uniform guidelines and standards for collecting the data, handling the data, and even doing geologic modeling with the data. 3D is really what's needed. So we have north, south, east, west, but we also have elevation. So we're going to have X, Y, and Z coordinates that are all involved. So we really need all of that data in the same 3D space. Now, the GeoCloud debuted in July 2020, live online. We formed an advisory group of the partner NRDs and groundwater professionals and agencies that deal with groundwater in the state to kind of steer that use of the GeoCloud and facilitate people using it. The original NRDs that went for that grant were the 6 ENWRA NRDs, the Lower Loop, the Central Platte, the Twin Platte, and the Upper Elkhorn. And they also formed another interlocal agreement to extend it even beyond the Water Sustainability Grant to keep it going. We had test holes, a grid of test holes done by the State Geological Survey across the whole state. And we had registered well logs that we could pull off the Nebraska Department of Natural Resources database. But now we have all these flight lines. We have a subsurface profile scan for each of those lines in addition to those point data that was covering the area. So what that was able to do is build out almost all of our hydrogeologic framework for eastern Nebraska. So if a landowner or a driller or a town was looking at siting a new well and they had a flight line nearby, they could pull that data and see right what's going on in that area. And agencies and private industry, if they're working on projects dealing with groundwater, then they have this additional data set that they can use. Now we have over 17,000 miles of added subsurface information just for eastern Nebraska with the airborne surveys. And with that, we got one of our main missions as an ENWRA group accomplished through the production of that. Further, the natural resources districts that are charged with the management of groundwater, of the quantity and quality of groundwater, as well as the community water supplies, they can make more informed, scientific-based decisions to sustain the resource. The framework that we built also allows for added parameters to be added on top of that framework of geologic information. So you can you can add pumping rates on there, you can understand groundwater, surface water interactions, the vulnerability of the resource, trends, modeling, prediction. It can just go on. The additional data sets you can lay on top of that framework. It also provides the researchers a whole nother data set in addition to the test holes and well logs that they can use. For an example, Dr. Jesse Corris of the CSD and Jared Abraham, who's been the main geophysicist on all these projects in Nebraska from the beginning, they did a project down in that Paleo Aquifer by Firth, Nebraska, that's where these sediments came from, where they actually mapped out the different evolution of that paleo channel with the different types of channels over time. And why that's important is because by knowing where those are, you can track where certain chemistry situations exist and know where there's good available water, where there's not. And that's not to mention even the mineral resource exploration. There, you can look for limestone layers, anything that shows up with the resistivity data in future years. The timing of the Water Sustainability Fund coming available and the stage that our ENWRA group was at with our application of that AEM technology towards our hydrogeologic assessment for eastern Nebraska, as well as the cooperative efforts with the basin coalitions of the NRDs working with the Nebraska Department of Natural Resources, that helped us capitalize on all this past assessment work that we had been doing in our area and all of our goals. So the results from the projects, you know, the example, the Nebraska GeoCloud project, making those results available in a 3D format for everyone, that complemented our partner goals, the scientist goals, the basin goals, the regional goals, the state goals, all to conserve and protect the water resource.
Thanks.
Well, as far as eastern Nebraska goes, I would like if you could visit enwra.org. That's our website where we have all the airborne data sets. We have the reports from each of the survey flights available, so every line that was flown in eastern Nebraska has a profile scan associated with it, and you can get those on the website. We also have, from about 2013 on, Google Earth data sets. So you can actually download these data sets and pull them up in Google Earth if you're looking at a particular area and touch on the dots and get the interpreted versions of the airborne survey data. You can also visit the website for the Nebraska GeoCloud project. It's at CSD, School of Natural Resources, UNL. You can just Google Nebraska GeoCloud and you'll find it. And you can request access to the GeoCloud where all the data sets are and see all the reports. And you can also read the guidelines and standards that were for airborne electromagnetic surveys and handling of the data and building models with the data. And I just say that collaboration and common goals and funding were all what made this project successful.